You know how some websites can just instantly tell you what a house is worth? It kind of feels like magic, right? Well, it's not. It's machine learning. And today, we're actually going to build your very first predictive model from scratch. We'll use a super simple real-world example to see exactly how an algorithm learns to make a prediction.
Okay, so let's dive in with a classic scenario. Imagine a friend of yours is trying to sell their house, and they hit you with that big, tricky question. So, what do you think it's actually worth? This right here is exactly the kind of problem machine learning was made for. So here's our game plan for the next few minutes. We'll start with the problem, then we'll look at how an algorithm learns with right answers. After that, we'll pick up some of the lingo, see how it all fits together, and finally build our very first straight line model. All right, so to help our friend out, we've got our hands on some real data from Portland, Oregon. It's basically just a simple list, right? It connects the size of a bunch of different houses to the price they actually sold for. Our whole mission is to use this data to predict the value of a house that's totally new to the market. Okay, so our friend's house is 1,250 square feet. The big question is, how can we use the prices of all those other homes to figure out a really good price for this one specific house? Well, one of the simplest ways to start is to just look at the data. Let's visualize it. If we plot every house's size against its price on a graph, you start to see a pattern take shape. And the easiest way to describe that pattern? You guessed it. We just draw a straight line right through the middle of everything. And boom! Just like that, we have a predictive model. Seriously? It's that simple to start. We just find the 1,250 square foot mark on the bottom, go straight up until we hit our line, and then look across to see the price. Based on this, we could tell our friend, hey, your house might sell for around $220,000. And that right there is the core idea of how this whole thing works. Now, this whole process we just went through, learning from data where we already have all the right answers, in this case, the actual sale prices, this is a really, really fundamental concept in all of AI. It's called supervised learning. And honestly, the best way to think about it is like a student who's studying for a test with an answer key. The algorithm is supervised because for every single house size we show it, we also give it the correct answer, the price it actually sold for. That's the supervision, and it guides the entire learning process. Okay, so within this big idea of supervised learning, our housing problem is a specific type called regression. Now, don't let the fancy name scare you. Regression is really just what we call it when you're trying to predict a continuous number, like a price. The other main type is called classification, and that's when you're predicting a specific category, like saying a tumor is either benign or malignant. All right, to really turn this from just a cool idea into a real process, we've got to learn to speak the language. So let's quickly go over the core lingo of machine learning. So here's our data again, but to someone who does machine learning, this table isn't just a list of numbers. Oh no, it's the raw material, the textbook for teaching an algorithm. This whole collection of data, every single house size and its known price, has a special name. We call it the training set. This is the textbook our algorithm is going to study from to figure out the relationship between size and price. And we use a specific letter, a lowercase m, to represent the total number of examples in our training set. So if our data has, say, 47 rows, then m equals 47. Simple as that. Next up, the input variable. That's the piece of information we're using to make the prediction. We call this x. So in our example, x is the size of the house. You'll also hear this called an input feature. And that brings us to the output variable, the thing we're actually trying to predict. We call this y. It's our target variable. For us, y is the price. So you can think of every single row in our data as a little pair, an xy pair. Okay, we've got the data, we've got the vocab. Now let's put it all together and look at the actual workflow. How do we turn all this raw data into a real working predictive machine? Well, it's a surprisingly simple 3-step process. Here's how it works. First, you take your training set, then you feed it into what's called a learning algorithm. You can think of this as the engine that just churns through all that data looking for patterns. And what pops out the other side? A function. And in machine learning, we have a special name for this function. We call it a hypothesis. And we usually write it as a lowercase h. And the job of this hypothesis, this h, is super straightforward. It's a function that takes a brand new input, x, like our friend's 1,250 square foot house, and it maps it to an output, y, which is our estimated price. This hypothesis, this is the whole point. It's the finished product of the entire learning process. So, Okay, we have this process now that creates this hypothesis function. But what does our H actually look like under the hood? What's the mathematical blueprint it's using to make these predictions? For this very first super simple model, we're going to make one big assumption. We're going to assume that the price, y, is a straight line function of the size x. This is the exact same idea we had when we just drew that line through the data by hand a few minutes ago. And here it is. This is the actual mathematical formula for that straight line. This equation is our hypothesis. And all it says is that our estimated price is equal to some starting number, theta 0, plus the size of the house, x, multiplied by some other number, theta 1. That's it. And this classic powerful model is called linear regression. Now, if you want to get formal, the full name for this is univariate linear regression. That word univariate is just a fancy way of saying we're only using one variable, uni meaning one, in our case, just the house size, to make our prediction. And that pretty much brings us to the end of building our first model. We've defined the problem, we've learned the language, and we laid out the blueprint for a predictive model. But this leaves us with a really fascinating question, doesn't it? I mean, out of all the millions of possible straight lines you could draw through that data, how does the learning algorithm figure out the perfect one? How does it choose the right thetas to find the single best fit? Well, figuring that out, that's the next big step on our machine learning journey.